All right, so we're going to continue practicing using the fundamental theorem of calculus correct notation. And what I'm going to add to this is I'm going to graph them using my calculator, and I'm going to interpret the definite integral using the area above and below. All right, so the first example, we've got a definite integral from 0 to 6 of this parabola. So again, first thing you do is you find the general antiderivative, which in this case would be 4x squared divided by 2 minus x cubed divided by 3, which if we simplify that, that would be 2x squared minus x cubed divided by from 0 to 6. So again, we're going to plug in 6 and 0 and subtract the 2. Well, 0 is easy because it zeroes out. So when we take our 6 and plug it in, it's 2 times 6 squared minus 6 cubed divided by 3, which that actually is going to zero out as well, minus 0, right? Because that whole thing zeroes out. This actually zeroes out. When we simplify this will come out to the same expression. 2 times 6 squared minus 6 cubed divided by 3. If you type that out in the calculator, it should come out to 0, right? Because 2 times 6 squared is exactly the same as 6 cubed divided by 3. Comes out 72 minus 72. And so the answer is 0. And it's okay to have a 0. Actually, I wanted one to have a 0, and that's kind of why we're going to talk about area. If I graph this function, all right, so I graph the original function in here, the 4x minus x squared, so I graph it on my calculator, and I'm just going to do a quick sketch of it. All right, so if I graph it on the calculator from 0 to 6, so it's a parabola that goes through, it's opening up, comes down, and comes down like that. All right, so what we're looking for, I'll draw my little off than what it is. Actually, my 6 is too far away. 6. Yeah, that's a little better picture. All right, so there's the 6 where my area stopped. There's the 0 where my area stopped. So if I shade it in, remember the integral is adding up all of the y values, the function values between 0 and 6. And so all of these function values are positive. All of these function values are negative. And so when we add them up, these positive values and these negative values basically cancel each other out. The area above the x-axis minus the area below is exactly the same. So they zero out. So this area here, we'll call that area 1. This area here, we'll call that area 2. Area 1 is the same as area 2. So when I take area 1 minus area 2, it zeroes out. So whatever that first part was exact, and the shapes are different. The area shapes are different, but it turns out that they're the same. And so the area of the top part cancels out the area of the bottom part. And so the answer in this case is 0, and zeros are perfectly fine, right? With definite integrals, you can have positive answers, negative answers, or 0, and 0 just means the area above and below are the exact same. All right, next example, and again, I'm going to compare it to areas. So this example, first thing you do is you find the definite integral. So our e term is our negative 4 e to the 0.2x. Remember, it's the antiderivative, so I divide by that 0.2 plus 5x from 0 to 3. And then I'm going to simplify. You don't have to since you're going to plug 0 to 3 in, but I just think it's easier to actually plug it in when I simplify. This would be negative 4 divided by 5, so multiply by 5, so negative 20. Negative 20 e to the negative 0.2x plus 5x from 0 to 3. And so we plug in our 0, we plug in our 3 and subtract. So we get 20e to the 0.2 times 3 plus 5 times 3 minus 20e to the 0 plus 5 times 0. And so this side is just going to be minus 20. Negative. Forgot my negative there. Forgot my negative there as well. Negative 20. Sorry, this is going to be negative 20. So negative actually means it's going to come out plus 20. So this is negative 20e to the 0.6 plus 15. And so if I'm looking at the exact answer, it's negative 20e to the 0.6 plus 35. And sometimes the MyLab does ask you for the exact answer, so that would be exactly what it is. The approximate answer, then I type that out on the calculator, comes out negative 1.442. And so that means there's more area below. All right, if I graph the picture, there's more area below on this function, exactly. So if I took the area above minus the area below, the exact difference is negative 1.422. So there's more area below. There's 1.422 units of area more below the x-axis from 0 to 3 than above. That's what this means. So if I graph the picture, that is what shows. So there's not a whole lot of difference, but that is what the picture would be. And so the graph that we graph, remember, whenever we're checking the picture out, this is the picture that we're going to graph. So when we go to the calculator and we type that in, give me a second while I type it in. So 0 to 3 is, again, all we're interested in. So 0 to 3, so it actually crosses at 1. 3 puts me down here. And so there's not a whole lot of area. So there's a little area above, there's a little area below. If I take area 1 minus area 2, that's the difference. So that means there's 1.422 units more area below the x-axis from 0 to 3. Just from 0 to 3. Again, we're only interested in from 0 to 3. Everywhere else it would be different, but that's what we would look at in this particular area. All right. So the next example. All right, so this one I'm just going to solve it. I'm going to talk about area, but I'm not going to draw the picture. All right, so the first thing I have to do is change this cube root of x, just like we did with derivatives. I have to change that to x to the 1/3 power. Minus 2 stays the same. So the general antiderivative is I add 1 to my power, so I get 1/3 plus 1, which would be 3 over 3. So x to the 4/3, which we would divide by 4/3, but instead of dividing by the fraction, which gives me an improper expression, multiply by the reciprocal. So I'm going to multiply by 3/4. So 3/4 x to the 4/3 is the first part. And then negative 2x is the second part from 1 to 8. So then we plug 8 in and 1 in. And so we get 3/4 8 to the 4/3 minus 2 times 8. That's the first part. And then plug in 1. 3/4 1 to the 4/3 minus 2 times 1. That comes out to negative 4. Negative 5/4. So I'm actually going to add 5/4. So exactly, if you did leave the fraction, a lot of times my lab will want the fraction. All right, so negative 11/4, which means it's a negative, which means there's more area below. Exactly 11/4 more area below. If I take area above minus area below, the difference is negative 11/4, or 10 1/4. 10.25, negative 10.25 if you did the, or not 10. 11/4. 2.75, negative 2.75. If you did the decimal approximate. All right, we'll stop the video there. We'll pick up the next one, which is an ugly one with fractions, but you should be able to do fractions. We'll do this in the next video, though. I'll start that in the next lesson.